All right. So for class today, I will be recording these all week because I know some of you will be in and out for testing and all of that. I even put this schedule up so I know who's going when and where. But our goal this week is to really get down to defining an acid and base. And we're going to talk about a couple of different acids and bases, or ways that we describe them. We have Arrhenius theory of ionization, which is one way of defining an acid-base relationship. And then we also have Bronsted-Lowry acids and bases, which is just another way. Basically, these two guys were working at the same time to describe the same things, are these two groups of scientists. Our goal today is just to be able to distinguish between an acid and base. We are really going to focus on Bronsted-Lowry today because that's more the one that's important in this class, because we want to deal with isolated hydrogens or isolated hydroxides. And that leads us to what a conjugate acid is and a conjugate base in that relationship or in that type of reaction. And then we may make it to the process of neutralization today. We may not. That may end up being pushed tomorrow, just depending on time. So our opening question today was name the following acids, also identify as binary or ternary. We did this before midterm. I actually had y'all starting to name acids and all of that. I'm really just trying to see what you remember. Tomorrow, I'll go back over the rules again briefly, just to, if you've forgotten. But let's go ahead. Numbers 1 through 4. Let's start with if it's binary or ternary. So HCl, is that a binary acid or a ternary acid? Binary. Wine. There's only two elements in it, so this one is a binary acid. And naming a binary acid, what's the first thing that we always start with? Hydro. So it's hydrogen and chlorine, so it's hydrochloric. The ide becomes ic. All right. Number 2, is it binary or ternary? Ternary. Remember, anytime you see a polyatomic ion in there, that makes it ternary. For ternary acids, what's the important thing to look at based off of the polyatomic ion? Okay, if it ends with ite, I-T-E, or ate, A-T-E, remember, ate becomes ic, ite becomes us, and we name it based off of the polyatomic. So this one is, so is it nitric or nitrate? NO2. Nitrate or nitrite, it is nitrite. So this one is going to become nitrous acid, because ITE becomes OUS. All right. This one again is binary or ternary? Ternary. And SO3 is sulfate, I think. Sulfite. No, this is sulfite as well. So is it going to be sulfuric or sulfurous? Sulfurous. Sulfurous acid. And then the last one, HBr. All right, so this is a binary acid, and it's going to be hydrobromic acid. All right, so real quick, before we before we move forward on anything, go ahead, take out your lab pages. For those of you that were here for the lab, take out your lab pages and take out your lab reports. There's one thing that I need to go through just because I should have given you this ahead of time, but and you wouldn't have known how to write a chemical equation for this. So on your lab analysis part, it for number 1 on your analysis part, it says what happens to solid CuSO4 penhydrate when placed in water, and it says write the equation. You would not know how to write the equation of dissolving in here based off of, because you don't have the rules for solubility and all of that. But basically, for that question, what you're going to have is we have our compound copper sulfate, penhydrate, so what are we going to discuss today? We're going to be looking at acids and bases as classes of compounds and basically start being able to recognize their properties as to identify it as an acid or a base. One of the things that we cannot do with acids and bases is just look at it as it's sitting here. Just looking at this, could you really tell what it is unless I told you this an acid or a base? No. So by observation of it, you don't know what it is. For all we know, this could be salt water, it could be plain water, it could be any number of things, but in reality, this is 3 molar hydrochloric acid. All right. No, that was nitric acid. That was 15.8 molar nitric acid. All right, so we're going to start looking at properties of acids. Does anyone recall some properties of an acid from way back when? All right, so one of the things that I heard, acids have a low pH. By low pH, what is the pH scale range from? All right, well, so it goes from 0 to 14. And I was hearing people say 0 to 7. So what is the range from 0 to 7? That's acid. That's for pH. All right. So 0 to 7 is an acid. From 7 to 14 is a base. Yes. Water is either acid or base. All right. We classify, and it just depends on what it's reacting with, and that's where we're going to talk about Bronsted-Lowry acids today, and how we define them. All right. And 7 is technically neutral. All right, which water, distilled water, pure water with no minerals in it, anything like that, is neutral. It's a pH of 7. But water is going to either act as a proton donor, giving away with hydrogen, which would make it an acid, or a proton acceptor, taking on an extra hydrogen, which would make it a base, just depending. All right, so that's one property of acids is pH. What's another property that you might remember specifically about an acid? All right, they're corrosive, meaning they will corrode things. They will start to break them down. All right, what's something else that we might remember about acids and bases, or acids in particular? All right. They cause indicators to change colors. Um, basically, an acid, and this is another property that we'll get in a minute. An acid is anything that will produce a hydrogen ion in solution. So if it has a free hydrogen or produces hydronium, H3O, and we'll see that. All right. What about, and I don't recommend ever doing this, but how think of like soft drinks or citric drinks. Like, how does it taste? Sour. They have a sour taste. Bases are bitter. So those are the types of properties that we're going to be looking at today. So let's go ahead. Let me give you the real notes. This was just kind of like a KWL is all I was doing right there. All right. So some properties of an acid.